In this video we look at odds. So we often hear about odds in the media or in normal conversation, but what exactly are odds? So in this video we're going to look at how to calculate odds. Basically, odds are a way of expressing confidence that an event will occur. We typically express odds as a ratio. So as an example here, 2 to 1 would be a ratio. So that just means, and as the next bullet says, the higher the ratio, the greater the degree of confidence. So what that means is that odds of 3 to 1 indicate a higher degree of confidence than odds of 2 to 1. The way that we calculate the odds in favor of an event is that we calculate the probability that the event happens and we divide it by the probability against. So here that is in words as a mathematical statement or as an equation. It's just the probability for an event. We'll call the event A for now. So the probability of event A, and we divide by the probability of A not happening, which is just A complement. So that's how we calculate the odds in favor of an event. If we wanted to calculate the odds against, you could probably figure out what the pattern is here, but if we want to calculate the odds against an event happening, we find the probability against, so the probability of A complement, so the probability that A does not happen, and then we divide that by the probability that A happens. So that's how we can calculate odds. Let's look at an example. So here we have a question that asks about finding the odds in favor of rolling a 6 on a standard die. So the possible outcomes on a standard die are the numbers from 1 to 6. And we're asked to find the odds in favor of getting a 6. So the odds in favor of a 6 are just equal to the probability of getting a 6. So the probability of rolling a 6, I'll just put that in here so we remember what that is, and divided by the probability of not rolling a 6. And we can calculate the probability of getting a 6 fairly easily. The probability of getting a 6, see there's 1 6 over here. That's our desired outcomes. So the probability of getting a 6. And it might be worth jotting this down off on the side. I'll do it so you can see it. So the probability of getting a 6 is 1/6. The probability of not getting 6, we'll just call that no 6 for short, is going to be 5/6. So now we can go ahead and calculate the odds. So we need the probability for and the probability against in order to calculate the odds. So the odds in favor is the probability of getting a 6 divided by the probability of not getting a 6. Well, that's just going to be 1 out of 6 divided by 5 out of 6. This is a very messy way to leave the answer, so we're going to simplify this. When we divide fractions, that's the same as multiplying by the reciprocal. So 1/6 times 6/5. So again, I'm just dividing the fractions. I'm taking this fraction here. I'm multiplying by the reciprocal of this 5/6, which is 6/5. Now notice here, and this should always happen, as long as your fractions are reduced to the same level, is that we have a 6 in the numerator and a 6 in the denominator. 6 divided by 6 is 1, so we can go ahead and reduce that, and that leaves us with an answer here of 1/5. So this means that the odds in favor are 1 to 5. So we would often write that, as we talked about earlier, as a ratio. So the ratio here being 1 to 5. So the odds in favor of a 6 are equal to 1 to 5. We can also find the odds against getting a 6. So the odds against getting a 6, we'll just do that over here. The odds against a 6 are just equal to the probability of us not getting a 6. So we'll call that the complement of A, if A is getting a 6, divided by the probability of A happening. Well, we already have these values calculated just up here. So the probability of a complement was 5/6, and we divide that by 1/6, and we get, again, we're going to multiply by the reciprocal, so we get 5/6 times 6/1, and here's that simplification that we can do again by reducing before we multiply. You could always reduce after you multiply. I just see this as an opportunity here for us to simplify right here. And we get a result of 5/1. Interesting connection here between the odds in favor and the odds against. So the odds against then are 5/1. So you can see here they just switch, right? So that's an interesting thing. The other interesting thing here is that the two values in our ratio, this one plus this one, added together gave us 6. So the 1 plus the 5 gave us the 6. That shouldn't come as a surprise because the 1 was the number of ways to have a success, which meant that there were 5 ways to have failure. So we should be able to add those together and figure out the total number of outcomes. So that's useful if we want to go backwards, and we'll see that in the next example. We can see the exact same thing happening over here, right? We've got the 1 and the 5. The 5 plus 1 gives us 6, so we see the total number of outcomes. Let's look at a second example. So here we're going to go backwards. It gives us the odds, and we need to find the probability. So based on what we just did on the other example, we should be able to kind of work backwards. So it says that the odds are 10/7. So 10/7 are the odds. It's asking us to find the probability. So this is important here to note. Are we asked to find the odds in favor or the odds against? So we're asked to find the odds in favor, and we want to find the probability in favor of A happening. That means that our numerator is going to be this 10, and our denominator is going to be the sum of the numerator and the denominator. And if you're not sure why, we'll kind of work it backwards in a second so you can see. So the probability of A happening is just 10/17. And if you're not sure why this works or how this works, if the probability in favor is 10/17, then the odds have to equal the probability in favor divided by the probability against. So we've calculated that the probability in favor is 10, probability against is 17. Well, if there are 10 ways to have a success, that means that there must be 7 ways out of 17 to have a failure. Just make this a little bit bigger so we can see that that's a fraction. So really we get 10/17 over 7/17, multiplied by the reciprocal, and we get 17/7 here. And we could just divide those out, 17s, and we get 10/7. So you can see kind of how this works. It goes back to the previous example where we talked a little bit about how the denominator is just the sum of these two values in the odds. So right in here. All right, let's try one more. Here's a question here that's asking, what are the odds in favor of rolling a sum of 8 or greater with 2 dice? In order to answer this question, we need to know how many different outcomes there are for rolling 2 dice. So this table over here is very useful. We've used it before. And we want to find the odds in favor of getting a sum of 8 or greater. So I'm going to highlight in this table the values, the sums that are greater than 8. So here they are in this section of the grid. And then all we're going to do is we're going to count them, and we'll be able to find the probability. Because remember, in order to calculate the odds, we need the probabilities. So the odds, let's switch that. So the odds here are equal to the probability for divided by the probability against. So the probability for, again, we can just do this off on the side, the probability for getting a sum of 8 or higher, we count these all up. There's 4 plus 3 more is 7 plus 2 plus 1 more, that gives us 10. So probability of a sum greater than 8, we'll say, is equal to 8, since there are 8 of them, 36 possible outcomes. And we get this as our probability for. Now we can reduce this Oh, hang on a second. I said 10, but wrote 8. Let's fix that up a little bit. So again, this is how many 8s there are. Sorry, how many sums greater than 8? We counted 10 of them, so we get 10 over 36. And we can reduce that fraction to something a little bit more manageable. We can divide the top and the bottom by 2, and we get 5 out of 18. So that's the probability of getting a sum greater than 8. So if this sum greater than 8 is our event, the probability of that event not happening, so greater than 8, whoops, let's fix that up. So we'll call this just a complement. So that's probability of not getting an 8 has to be everything else. So just a reminder that there were 36 possible entries, 10 of them were greater than 8, so that must mean that 26 are not. That's 26 out of 36, and we should be able to divide the top and the bottom by 2, giving us a total of 13/18. So now we can calculate the odds. Just find the probability for over the probability against, and again we get that nice pattern happening where we're going to divide by a fraction. The denominators in both of those fractions are the same, so we'll get some nice simplification happening. So we get 5/18 times 18/13. Divide out the 18s, and we're left with 5/13 as being the odds in favor of that. 5 over 13, and as I said earlier, we often express this as a ratio, so we would say that the ratio is 5/13. So a little statement, therefore the odds of getting a sum of 8 or greater is 5/13. So that's how we can calculate the odds. That's what odds mean, and used a lot, especially when we talk about sort of casinos and betting and all that other sorts of thing. Big sport games often play favorites and have odds based on how well some people think the different teams are going to do.